Hi everyone. The next topic is the ANOVA F-test. Sometimes it's called just ANOVA, sometimes just called F-test. So this test is different from t-test because it can test multiple parameters at the same time. So basically, the lowercase omega here is null hypothesis, and uppercase capital omega is the alternative hypothesis. So null hypothesis is that y is this linear model with q parameters, and alternative is a larger model with p parameters. So the difference is parameter beta q to beta p minus 1. So null hypothesis can be expressed as this way. You can think about just a larger model, capital omega, and if this hypothesis is true, then that becomes lowercase omega. So this is null hypothesis. And how to test? The idea is using residual sum of square. So lowercase omega is smaller model, capital omega is a larger model. If additional variables are useful, then residual sum of square for the second model should be much smaller than the first model. So this difference becomes large if those parameters are non-zero. But of course, we have to have some normalizer. So we divide this by basically the Rss omega, so smaller one. I mean, the larger model with smaller residual sum of squares. And also that we have some normalizer, p minus q and n minus p. Then this distribution follows, this random variable follows F distribution with degrees of freedom p minus q and n minus p. So F distribution have two parameters, and the shape that actually depends on these two degrees of freedoms. So p minus q is called numerator degrees of freedom, n minus p is called denominator degrees of freedom. And since if null hypothesis is true, Rss omega and Rss capital omega has small difference. So basically, if the difference is large, we reject null hypothesis. Difference is large, then additional parameters are useful. So that means that we reject null hypothesis. So F distribution is typically this shape. If we have x-axis and y-axis here, then F distribution looks like this. So that means that so-called F statistic here is large, we reject. So that means, for example, test with 5% significance level, that we think about the threshold here. Then if F statistic fall in this range, we reject null hypothesis. Otherwise, we don't reject null hypothesis. So this is the structure of the F-test. So now that we proceed to our examples. So we set up two linear models. So first one is linear model AA. So only percentage of African American is the predictor. And the second model, we have two predictors, percentage of African American and the equipment. And remember that the equipment, we have 5 types. So OSCC and OSPC and the labor and what? We have some 5. Paper and punch or something. Punch and so we have 5. Okay, so 5 categories for this categorical variable. So that is equivalent to 4 parameters. And we want to see if the entirely, so overall, so this variable, or I would say these 4 variables are useful or not. And actually this ANOVA of linear model. So this one model should be nested in another model. Then the result is here. And okay, so you can see the p-value. So p-value is large, so we don't reject null hypothesis. But okay, so let's see the statistics one by one. Okay, so basically, this is the statistic for full model, and this is the smaller model. So this is RSS larger model, so omega, and this is RSS lowercase omega. And this is actually a difference. So this is actually RSS smaller omega minus RSS larger omega. Okay, and the numerator degrees of freedom is 4, and actually this is df for numerator, maybe df num. And 153 is degrees of freedom for denominator. So actually, so this F statistic, actually this is 1.09. So this is calculated by 0.0025911. So this comes from here, divided by 4 over RSS capital omega. So that is 0.090691 divided by 153. So this is actually equal to 1.0928. And based on F distribution is roughly speaking centered at 1. So it's not symmetric shape, so I cannot say center, but maybe 1 is around here. Okay, so then 1.09 is around here. So this area is actually 0.3622. So this isn't really small. So this F value is typical number when under null hypothesis. So we fail to reject null hypothesis. So F-test so the ANOVA table can read in this way. So next one, the also F-test, but this is leave one out F-test. Okay, so the full model is Y is equal to beta naught plus beta 1 times percentage African American, and beta 2 times the equipment, the OS CC plus beta 3 OS PC and beta 3 punch or beta 2, 3, 4, 5. So this is the full model. This is full model. Then we compare this model. So this is full model. This with another model. Okay, so omega 1. Omega 1 is Y is equal to beta naught plus, okay, so we miss this one and the other term, beta 2, beta 3, beta 4, beta 5. So just leave one out. So we can see whether or not beta 1 is useful. And that test result is here. Actually, if we miss this variable, actually that we have significantly worse result. So percentage of African American is useful information to predict undercount. And actually it can lead in the same way. So the RSS difference is here. So you can see this is RSS omega 1 minus RSS full model. The full model, maybe we say just capital omega. So capital omega. So this is the one. And the degrees of freedom is 1. Of course, this is just one continuous variable, one parameter. So degrees of freedom is 1. then what's the residual sum of square for the larger model? The residual square for larger model is this one. So this is basically the denominator. And the degrees of freedom is remembered at 153. So I will say that originally we have 159 observation, and we have in total 6 parameters. So 1 parameter for percentage African American, 4 for equipment, and 1 for intercept. So we have 6 parameters, so 153 degrees of freedom is. Okay. So we get the F value, that's this 9.84. This is actually obtained by 0.0058368 divided by 1, because TF is 1, over this 0.090691, then divided by 153. So this is actually equal to 9.846. And F statistic is actually on average 1 approximately. So actually the 9.8 is very large number. So it's almost the far right part. So 9.8 is around here. So p-value is very small. So percentage of African American coefficient is not 0, significantly different from 0. So same test can be done for equipment. And actually this is not really significant. Yeah. So this is the ANOVA F-test, leave one out. So basically this table gives the many ANOVA tests. So in this case only 2, but for each variable that we test the significance of parameters. So first block is this one, the second block is this one. If we have more variables, that we do more ANOVA at the same time. And here that we consider the special case with Q is equal to 1 and P is equal to 2. So smaller model, we only have intercept, Q is equal to 1, and larger model, P is equal to 2. So we have 1 additional variable, x1. Then ANOVA test basically compare these two. So that means we test if beta 1 is equal to 0. So this test can be done by t-test or f-test. And actually this result is exactly the same. And actually the square of the t-distribution is f distribution with df1, and the degrees of freedom is t-distribution. So these two tests correspond to each other for this specific case.